Section 3.2.29. Scores of an IQ test have a bell-shaped distribution with a mean of 100 and a standard deviation of 12. We're going to use the empirical rule to determine the following. Now recall that if data have a distribution that is bell-shaped, the empirical rule can be used to determine the percentage of data that lie within k standard deviations of the mean. In our question, k is equal to 12 because the standard deviation is 12. Now the empirical rule says that if a distribution is roughly bell-shaped, the following is true. Approximately 68% of the data is going to fall within one standard deviation from the mean. Approximately 95% of the data is going to lie within two standard deviations of the mean, and 99.7% of the data is going to fall within three standard deviations of the mean. So here's our bell curve. Okay, we have 100, which is our mean. Okay, this is one below the mean and one standard deviation above the mean. So we can see here that if we add 12 to the 100, which is this standard deviation, we're going to get 112 over here. If we subtract 12, we get 88. Okay, and then if we want to go another standard deviation below the mean, we're going to subtract another 12 from 88 to get 76. And over here, we're going to get 124. And then if we go three standard deviations from the mean, we're going to then subtract another 12 from 76 to get 64. And adding 12 to 124 is going to give us 136. Okay, so if it's within one standard deviation above and below the mean, the empirical rule tells us that 60% of the data is going to fall within that one standard deviation of the mean, which means we have 34% here. That add them up gives us 68%, one standard deviation below and above the mean. Now, if we add and go two standard deviations above the mean, it's going to be 95%. So if we add that 13.5 to the 68, it's going to give us 95%. And then if we go another standard deviation above and below the mean, meaning three standard deviations, we're going to add 2.35 plus 2.35 plus 13.5 plus 13.5 plus the 68% is going to give us 99.7%. So what that means is anything with one standard deviation is 68%, two standard deviations is 95%, and then three standard deviations is 99.7%. And then the remaining is outside, which is 0.15%. So our question states for part A, it says, what percentage of people has an IQ score between 88 and 112? So we know that here is 88, there is 112. And then if we add these two percentages together, the empirical rule, when we add 34 plus 34, tells us that it's going to be 68%. So again, to answer this question, add up the correct percentages from the graph. The graph indicates that 34 plus 34 people have an IQ between 88 and 112. So the correct answer is 68%. Next, we want to be able to find what is the percentage of people that has an IQ score less than 676 or greater than 124. So, less than 76 is anything from here and then on to the left. So that means we have 0.15 and 2.35%. So that means that the graph indicates that 0.15% plus 2.35% score less than 76. And then we got to figure out greater than 124. So here is 124 or greater. So that means 2.35 and 0.15% are also the same percentage, which is greater than the 124. So the correct answer is taking 0.15 plus 2.35 and multiplying it by 2 to give us 5%. So 5% of the data here has an IQ score less than 76 and greater than 124. Part C. It says, what percentage of people has an IQ score greater than 136? So let's take a look. Here's 136. We want to know everything that's greater than that. Well, we have 0.15%. So from the graph, we can see that 0.15% of the people has an IQ score that is greater than 136.